Yeah, hi everyone. In this video, we discuss Chapter 10, Mechanical and Sound Waves. This topic actually have few subtopic, which is 10.1, Properties of Waves, 10.2, Superposition of Waves, 10.3, Sound Intensity, 10.4, Application of Standing Wave, and lastly, 10.5, Doppler Effects. So you can expect that this topic will be a little bit longer compared to other topics. And in this video, we will focus about 10.1 first, which is properties of waves. Okay, definition of waves is actually, it is defined as propagation of a disturbance that carries energy and momentum away. Okay, so propagation is more like a motion of a disturbance. This one is, you can imagine that this one is something like a ripple that carries energy and momentum away. So remember that the wave carries energy and momentum. Okay, for mechanical waves, it travels through particles of a medium to transfer energy, and most importantly, the particle itself does not travel, okay, but the particle oscillates. Okay, example, if I have a rope, okay, and then maybe this is my particle, okay, so the particle actually doesn't move, like it doesn't actually travel from left to right, but it actually just travel, or what we call vibrates in y component. Okay, but at the same time, this rope is actually transferring the momentum as well as the energy to the other side of the rope. Okay, so wave actually do have direction, like maybe to the left or to the right. So this is the direction of wave. Okay, and over here we have the motion of particle. So it's a little bit different. Okay, this one is what we call v particle, and this one is what we call v of the waves. Okay, we'll go into detail later on, but for now I just want you to imagine that the particle doesn't move, but it does transfer the energy. So example here would be other examples such as earthquake, water waves, or sun waves. So there's few types of waves. One is progressive wave, another one is standing or stationary. So we learn all of this in this chapter. Okay, what you need to know in 10.1 is actually you need to be able to define, so this is the learning outcome. You need to be able to define lambda and k. What is lambda, what is k? You need to be able to use this equation to solve a problem, and then you need to be able to differentiate between the v particle, which is what we call vy, and v wave. I think they use vy, so I'm going to change it to vy. Vy here because the particle travel in y component, vibrates in y component. And then you need to be able to draw a graph of y against x and y against t. Okay, first of all, I would like to introduce some of the key quantity that you will be using in this chapter. Okay, first of all, it's about lambda. Okay, lambda here actually defined as the lambda is actually defined as a distance between two consecutive particles which have the same phase in a wave. Okay, example. Okay, what does it mean by in phase or not in phase? Is that if, let's say, if I have this point over here and that point over there, okay, you can imagine that this is a point where if I have a particle at the end over here, the particle will try to move downwards after it because it's already at the maximum. So after that, it will try to move downward. Okay, and in the same case you have over here is that you have a particle that is actually at that particular height or at that particular position in y component, and at the same time it try to move downwards. Okay, so these two position is what we call in phase. If I put this one as point A, maybe I can put this one as point C. So this 2 point is actually in phase. Okay, it has the same height, which is at the amplitude, and at the same time it is actually trying to move in the same direction. So A and C is in phase. Okay, example of something that is not in phase, maybe I can put somewhere over here. Okay, let's see if I put that one over there, B. Okay, so you can see that all of these is actually trying to move downwards, yes. Okay, but then the position of Vy is not actually the same, so it is actually at a different position, so you cannot say that A and B is in phase. So I just write this one as out of phase. Okay, so if the question asks you state the antiphase, if antiphase, then it is actually at the opposite over here. Okay, so the most important thing is that you need to be able to determine when it is actually in phase. Why? Because this is when the lambda or wavelength is defined. Okay, so I can say that since this 2 point is in phase, so and these two actually consecutive, okay, I mean berturut, so this is where we put our lambda, which is wavelength. Okay, the SI unit for lambda is in meter. Okay, actually you can state that this one is 1 lambda as well lah. Sometimes students tend to think that it is actually one complete cycle. This is basically the same thing lah. Okay, period T is defined as the time taken for a particle in the wave to complete one cycle in the period T. Apa ni? Okay, period is defined as the time taken for a particle in the wave to complete one cycle. Okay, that is actually the definition. Okay, masa yang diperlukan untuk wave complete satu complete cycle. Okay, so it is basically the distance is basically same with the lambda lah, one complete cycle. So I can put this one as T as well. I'm trying to find a diagram that maybe you guys can refer to after this. It's actually in the page number 10. Okay, in the page number 10, that one is actually, it's a very good diagram. It has all the details and you can refer to that over after this. Okay, so period T is the time taken to complete one cycle. Okay, it is actually equals to 1 over F. Okay, remember that F is actually frequency lah. How many time the wave complete cycle in 1 second. Okay, and then the other thing is about amplitude. Amplitude is simple lah, tak ada masalah. There's no issue with this. Maximum height is what we call the amplitude. I just put this one as A. Okay, now another important things that you need to know is about crest and trough. Crest is at the peak. Okay, so here you can see that you can say that the maximum ataupun at the point where it has a maximum height, that one is a crest. So over here it's actually the crest, and the lowest part is what we call trough. THTROUGH. Okay, so this is some of the important bits that you need to understand. Okay, things like period T, frequency F, and lambda you already learned before this one. Amplitude also you already learned. So the difference here, you need to know about crest and trough, as well as the in phase and out of phase. Okay, And then also, of course, we have the velocity of wave. Okay, velocity of a wave is actually a constant. Okay, it does not change over time. If you have this let's say you have a wave that traveling at 5 meter per second, from the start till the end, the values of velocity will remain the same, and dia tak berubah. Okay, defined as the distance traveled by a wave profile per unit time. So that one is actually you have a common equation, tak adalah complicated pun. V is equals to lambda over lambda over t. How do you get this equation? This one actually the displacement for one complete cycle. This is the time for one complete cycle. So this is basically just V equals to S over T, right? But if you have the values of one complete cycle, so you can use this formula lah. I can rearrange the T period there, since the T is equals to 1 over F. So it becomes lambda equals to, V equals to lambda F. Okay, the unit is ms minus 1 lah. Okay, and then you have one more important thing, which is about the particle velocity of a particle. So previously, for velocity of a wave, it is a fixed value, it doesn't change with respect to time. Okay, but the V here represent over here, like I told you before lah, V of the wave determines the velocity of the wave lah, how fast it's travel to one position to another position. But for Vy, ataupun sometimes it just state that find the velocity of the particle. So the particle here is the keyword for Vy. Okay, it is actually the vibration punya velocity, ke atas and ke bawah, how far it moves up and down, and those numbers is actually changes. So you would expect Vy at here and Vy at there will have a different values. Okay, it's very similar to the one in the simple harmonic motion, where at certain position you have a specific Vmax, Vmin and things like that. Okay, basically still apply the same concept. So I'm going to write over here V particle, velocity of particle. Okay, you will have an equation E omega cos omega t. I'm going to explain very soon how do you get this equation. And since this one is the amplitude of the y Vy, so you can say that this is actually the maximum Vy. Okay, and then also you need to know about wave number. Maybe this seems like a new for you guys. It is actually defined as k equals to 2 pi over lambda. Okay, and then if you want to calculate k, you just have to plug in the lambda. Okay, and then you have the equation of progressive wave. So if you guys still remember previously, kalau dekat simple harmonic motion, you have y equals to a sine omega t plus phi, right? So the phi here is a constant, it does not change with respect to time. Okay, and then simple harmonic motion, you already did the experiment. It is actually a motion where it repeats by itself lah, left and right, left and right, left and right. Okay, but here it's a progressive wave, it moves as the time goes on. So you have two variables. So instead of phi, actually you have kx. Okay, and this equation depends on x and t, so t and x over there. Other than that, it's a constant, like a, omega and k is a constant, but t and x changes with time. Okay, so like I told you before about the velocity of the particle over here, so actually I can explain it one more time over here. Okay, notice that I use a different term. Over here I use particle vibration, Over there, I use velocity of a particle. Both also correct, both also used in the exam. So to get Vy, you have to differentiate the y equation, which is above here lah. So this is the general equation. Okay, obviously you have the derivation on how to get that one. I'm not going to focus on this, but I want to focus on here, the Vy there. So if you want to differentiate this equation, the above equation, so I just substitute the equation y, which is a sine omega t plus minus kx. Okay, why do we have a plus minus over here? Because the plus and minus actually represent the direction. Okay, the plus here means the wave travel to the left. The negative means the wave actually travel to the right. Okay, sometimes in exam they might give you this equation. Dia tak akan letak plus minus lah. They will put you either plus or minus. So the last question, sometimes they ask you to find the velocity of the wave and state the direction of the wave, ke kiri ke kanan lah. Okay, here from this equation, if I want to go details, the A is amplitude, the omega is equals to 2 pi f or 2 pi over t. Both also correct. Okay, and then k here you have a wave number which is equals to 2 pi over lambda. Okay, sometimes they give you equation, they ask you to deduce the information, or sometimes they give you information and then they ask you to write down the equation. So you need to be able, you need to familiarize yourself with this term lah, A, omega and K. Okay, back to this one. If you want to differentiate this one, what will happen is that you will get Vy equals to sine becomes cos, right? And then this one is a differentiation with respect to t, time. So kx, sorry, k here depends on x. I mean, this term depends on x, right? For this one, it depends on t. So this one doesn't change with respect to time, so you can assume that this is a constant. So when you differentiate a constant, you actually get a 0. But inside here, it will remain the same. So you have omega t, you differentiate the t, becomes omega t to the power of 0, which is 1. So you have omega over there. And then kx, it does not really depends on time, so that one becomes 0. So I can rearrange this one. Should get a omega cos omega t plus minus kx. Okay, this is the exact same formula with the above here. Okay, and normally they might give you the position x. Okay, so you can substitute inside the equation, and then and then you have a constant over there. Okay, sometimes you can substitute first or you can substitute later. It's up to you. Okay, if the position is at 0, then you can cancel out this one, this term straight away. Okay, so notice that this is the amplitude, so this would be the maximum V. Remember, we are talking about the particle. Okay, now how about the graph? Okay, so if the question asks you to draw a graph, you basically need one more information. Okay, if they ask you to draw graph of y against t, you need to have the values of x. Okay, kalau dia kata draw y against x, you need to have the values of t. Okay, sometimes they ask you to draw both of these equations, both of the graph, so you should be careful. Okay, now one more thing, I hope you guys still remember, if you have a negative sign, this one becomes a negative. If you have a negative cos, this one becomes a positive. So it's something to do with the if I'm not mistaken, it's about odd and even. I'm not sure. But if you have a cos, if you have a negative, sorry, cos negative x, it becomes cos. But for sine negative x, the negative, you can bring it outside. Okay, back to this equation. If I want to draw, basically I need to have another values. Example, if I want to draw y against t, that means I need to have a values of x. Okay, let's say x is equals to 0. Then you will left with y equals to a sine omega t, which is basically just a sine graph. So if you want to draw, I draw this one a little bit small, but you really do need to draw it bigger. So it's a sine graph. It's not a negative sign, it's not a cos, it's not a negative cos, it's just a sine graph. Okay, and you need to be able to label over there lah. Kalau this one is in time, so label here with the period. Jangan label this sebagai wavelength pula. Okay, you need to be the same. Okay, and then if they ask you to draw y against x, okay, they need to give you the values of t. Okay, let's say the t is equals to 0, and let's say you're drawing y equals to a sine, okay, the omega t becomes 0. Let's say I put this one as negative kx, okay, just to make things interesting. So negative, kalau sine, you can bring the negative outside. This one become negative a sine, sorry, kx. Okay, why do you need to bring it outside? Because this is not something that you can draw. Okay, but if you rearrange, becomes like this. So this one is just a negative sine graph. So again, you draw the axis, make sure you plot correctly. It will be y against time. Sorry, this one is y against x. And then it's actually a negative sine graph, so it looks something like this. So again, you don't really have to memorize anything. Kalau yang ni, you label lambda. Okay, so if t exists, you have to find the period and you label over here. If this one is x axis, you have to find the lambda and label it over here. Okay, I think that's it for this video. We continue later in the next video. Thank you.